Remember for inverses that if we plug the original into the inverse and simplify, it'll equal x. Or if we plug the inverse into the original equation, again, when we simplify, will equal x. Also for inverses, the domain of the inverse is the range of the original, and the domain of the original is the range of the inverse. Also, the graph of an inverse would be the original mirrored over the line y equals x. And if an equation has an inverse, remember that we switch x and y and then solve, and that's how we can find the inverse of that. So what we're looking at now is we're going to look at sine, cosine, and tangent, and we're going to look at the inverses of those. So remember, first thing we want to look at is a regular graph of each of these. If we're talking about sine, then our domain is all real numbers, and our range is from -1 to 1. That's also true then for cosine. Cosine, we have our domain is all real, and our range is -1 to 1. For tangent, our domain is all real numbers, except for odd multiples of pi over 2. Because remember, tangent is sine over cosine. When we have cosine pi over 2, that is equal to 0. Then our range for tangent is all real numbers. So here's our normal sine graph, and we have y equals sine of x. We're plugging those values in for x, and we find our sine curve. And if we're talking about finding the inverse of this, if we imagine our line y equals x coming across here, and we're going to reflect this over that line, we're still going to go through the origin, and right here where we cross, we'll go through that point and this point, but that inverse is going to curve, and instead of having our curve go along the x-axis, it's now going to follow along the y-axis. So that's how our inverse graph would look. Now, because of that, we want to think of this as we're finding that y-coordinate. We're plugging in values for x, and we're going to find the y-coordinate. Now, because of the way this graph works out, when we're talking about the inverse, we still want that inverse to be a function, so we have to restrict the domain. Because if we don't restrict the domain, the inverse is not a function. So because of that, we're going to restrict it so that we're looking at that domain is going to go from -pi over 2 to pi over 2. The reason we're restricting it to those values is because that gives us our positive and our negative values for sine, and then we're talking about these values right along here and right along here, giving us both our positive and negative values for sine to represent those values in the inverse. So if we restrict the domain of our original sine value, we're talking about this side of the unit circle. So here is pi over 2, and here's -pi over 2. And again, that gives us all of our positive values on this side, all of our negative values on this side for sine. And so if our domain for the original is from -pi over 2 to pi over 2, then that would be the range of the inverse. And we already know that our values here, 1 and -1, that's going to be the domain then for the inverse negative 1 to 1, and we're talking there. So we said earlier that we had up with the normal equation y equals sine of x that we're finding the y coordinates. So now here when we're looking at the inverse, x is equal to the sine of y. What we can do when we're rewriting that when we solve, that's going to be y equals, and this is where we move this over and it becomes the inverse sine of x. And what we're doing is we're finding the angle with the y coordinate given. So, for example, if we think about our unit circle and we want to find the exact values. What if we're going to take the inverse sine of negative square root of 3 over 2? Or the inverse sine of 1/2? Or the inverse sine of negative square root of 2 over 2? Where on your unit circle, and remember what we've restricted it to, where would we find those values? You should pause the video and find that. So we need to pay attention to our unit circle here, and if we're talking about a negative value here, then that's going to be part of this negative angle on this side. And so remember, we want to write that in terms of we're going from 0, we're coming down, so it's going to be between 0 and negative pi over 2. So this value, we're not going to write it as coming all the way around. That would not be part of our domain of the normal or the range of our inverse. So what we're going to write this as a negative angle, negative pi over 3. Here we have sine of 1/2. So now we're going up this direction. Where is sine equal to 1/2? That would be at pi over 6. Here it's negative square root of 2 over 2. Again, we're coming down. We're going to write this as a negative angle. We're at negative pi over 4. Now we're working with cosine, and remember with sine, our sine values are the y coordinates on our unit circle, so cosine, now we're looking at those x coordinates because our cosine is our x values on that unit circle. And here's our original graph. So if we're thinking about how that, again, it's waving along the x-axis, so now we're going to have our wave coming along the y-axis as we work our way along here for the inverse, right? Now, our domain, same idea here. We want to have both positive and negative values when we're talking about the unit circle for cosine. And because we're talking about those x values, then what we're going to look at for cosine is we're going to be looking at the top half. So that we have the positive values over here, negative values over here. So we're going to go from here all the way to this side. So from 0 to pi gives us all of those positive and negative values for cosine. And that way, by again restricting the domain, now we're able to have our inverse be a function. Because otherwise, when we're talking about that inverse, it's going to, you would not pass the vertical line test. We want the inverse to be a function, so we're going to restrict the domain. The range is still from negative 1 to 1. So now when we look at that inverse, so we're saying that x is equal to the cosine of y. So again, solving here, we have y is equal to the inverse cosine of x. So what we're doing is finding the angle with the given x coordinate. All right, and again, domain and range, we're switching here, so now our domain for our inverse is going to be from negative 1 to 1, and the range for the inverse is going from 0 to pi. So again, we want to find those exact values. So now let's see, what if we have the inverse cosine of 0, or the inverse cosine of negative 1/2? Where on your unit circle do we have 0 and negative 1/2? Pause the video, find those values. So looking at the unit circle, if we go all the way to the top of that unit circle, right at pi over 2, that's where our cosine value is equal to 0. And if we go over into the second quadrant, we see that cosine is equal to negative 1/2 at 2 pi over 3. Okay, so now we're looking at tangent. So tangent for our normal graph, we have y equals tangent of x, and remember we have our asymptotes at negative pi over 2 and at pi over 2. We have those because we have sine or cosine at x value is 0. That's where we get our vertical asymptotes. And remember that this tangent, the wave, we would also have it coming across here, and it continues forever. And so now when we start talking about restricting our domain, what we want is, we know that we're going to have all of our values of tangent in between negative pi over 2 and pi over 2. So that's what we want to look at for a domain on this. It does not include those, so we're having parentheses, negative pi over 2 to pi over 2. And then our range is all real numbers. So if we start thinking about what that's going to look like when we graph the inverse, well, what we would have is we would have our, now we have our asymptotes going to be vertical asymptotes. And that graph is going to come across this direction. And it's going to cross here, goes through the origin again, crosses right there, and continues that way. And so that graph now still gives us, now our domain for the inverse is going to be all real numbers, and that range is negative pi over 2 to pi over 2. So we just said, now we're talking about x equals, we switch this, tangent of y, so we rewrite it, take the inverse tangent, and again that domain becomes our all reals, and the range of the inverse goes from negative pi over 2 to pi over 2. And when we're talking about the unit circle, well, there we just said it right here, our domain, we're talking about up this direction to pi over 2, and down this way to negative pi over 2. We're talking about this side of the unit circle for those values for tangent. So again, we're looking at if we're going to find exact values. Again, using our unit circle, if we're going to find the inverse tangent of negative 1, where on the unit circle would we have a value at negative 1? Or what about the inverse tangent of square root of 3 over 3? Where do we find those values on the unit circle? So when we're solving for tangent, remember we have y over x. So if we're looking at negative 1, we're looking at where we're going to have negative 1 over 1. These values are the same. So negative square root of 2 over 2 and square root of 2 over 2 would give us that negative 1 value. Now, that would be at 7 pi over 4 on the unit circle, but remember, that's not in our range. We need to think of it as a negative pi over 4 to get to that angle. Right? So the answer here, where tangent is equal to negative 1, is negative pi over 4. As far as square root of 3 over 3, we would want to rewrite that as 1 over the square root of 3. That gives us values of, if we're kind of undoing our work as we go here, maybe a 1/2 for our y coordinate and a square root of 3 over 2 for the x coordinate would simplify and give us this value with our rationalized denominator. So we're looking for coordinates of, again, here's our y coordinate, here's our x coordinate, square root of 3 over 2 and 1/2. Where does that happen on the unit circle? That's at pi over 6. So here, inverse tangent of square root of 3 over 3 would be at pi over 6.